Hi, I'm Boris Kaufman. I'm a senior solution architect at AWS, specializing in broadcast workflows. Here we are at the centerpiece of our story this year. The master control room is the centerpiece that takes all the feeds that are being produced, the program output that's being generated in the production control room, and delivers that to the operators to take decisions about how we are sending those feeds downstream. So the demonstration here is trying to focus on the concept of having a complete virtualized master control. The solutions we are using here are using a combination of transport streams and asynchronous fabric technologies that allow you to route between signals, not in the transport stream domain, but in the actual frames uncompressed domain. The two master control switcher positions we have here have the ability to do transitions, insert downstream keyers, DVEs, logos, so everything that is required to produce a high quality channel to be delivered to multiple destinations. This can go over the air for television viewers, this can go over the top as streaming platforms, and the most important part is that for an operational perspective, the latency, the feeling on operating those equipments, it's very close to a real on-premises system. All the monitorings you are seeing are WebRTC based, so this is near real time. You can see the actions that you are taking on the control panels immediately being reflected on the monitoring screens, and all those feeds available here are displayed near real time. The last screen we have here, it's more like a distribution type of multi-viewer, so the feeds that are ready to be delivered to the viewers pass to a last final check. You guarantee that all the parameters are correct, the transport streams are good, no alarms, and after that, we are secure that these feeds can go over to the viewers without any disruption. We also have distribution over internet using services like Media Connect to deliver that to international markets, but we also are doing a real terrestrial distribution here, delivering this content over the air, demonstrating the capabilities of the ATSC 3.0 distribution system. And over here, we are doing our ATSC 3.0 demonstration, where we are taking the channel we are producing on the master control room, and we are sending into the whole root-dash ATSC 3.0 signaling chain in the cloud. With that, we are able to combine multiple services, cloud-native services, with services that are being encoded on premises. And in partnership with Sinclair, we are using a transmitter site here that it's actually putting out this signal over the air. So you can combine all those signals in the cloud. And as you can see here on the television, we have the AWS channel and the Sinclair Broadcast Group local channels that are being all multiplexed into the same stream and delivered over the air. And finally, over here, we have our ground-to-cloud, cloud-to-ground latency test demonstration. We have a source here in the booth. We are encoding it using JPEG access, using TR07, also encoding in HEVC transport stream, send over to the cloud using SRT, and finally using NDI high bandwidth. As you can see here on the monitor, we have the source at the booth, and you can compare how the other encodings are later compared to the source. So you can see JPEG access has the best speed, followed by NDI, and then of course the SRT HVC is a little bit more late because it takes more time to actually do the transcoding. The workflow is being send those feeds to the cloud, reflected back to the ground. So it's just like a round trip test that we are doing here. And if you want to learn more, come talk to us at AWS. Thank you very much.